This is the video lesson for the lesson on 17th of January, Friday, that some of you were absent for the A Maths lesson. Now, in this lesson, we continue with topic 12.1 on the derivatives, basically dy dx and differentiation, and some of the basic rules. Now, up to this point, we have already covered some basic recall questions on indices, how to convert from negative power to positive power, from positive power to negative power. We also recall that a power 0 is 1. In particular, we learned how to convert square roots. We also learned how to convert indices like this. Now, we also remembered how to write the following as negative indices. Right? In particular, this, and this are important for today's lesson when we continue with power rule and the constant multiple rule. For the following question, we also recall how to write this in negative indices. Right? Now, up to that point, we have skipped a certain number of pages. Can we now move to the page that was on presentation? Okay, the presentation of differentiation. Now, differentiation is the method of obtaining the gradient function, and as the name suggests, for the rest of this chapter, we are going to calculate gradient. Now, the way to do that is to use this function known as the dy dx, okay, which is known as the gradient function. There are a few ways to write gradient function. Now, let's zoom into the three ways. First, if y is given, so y equals to x squared. When the letter y is given, the gradient function is simply dy dx, and you can perform the power rule to obtain 2x. That's method 1. Method 2, when they give you a function, let's say f of x. Okay, they don't give you y anymore, they give you f of x. If you differentiate, you get something called f prime x. There is a symbol here, f prime x. On the right hand side, you proceed to do the power rule. The last case is when both the y and the f are not given. What would they tell you? They will just tell you this, x squared. Now, how do you differentiate? You must introduce the symbol d on top over dx, and then you bracket the original question, copy it down below. Now, how you read it is, we are differentiating x squared with respect to x. Okay, so let's see again. Differentiating is this symbol. X squared is this one. With respect to x refers to this symbol at the bottom. So we read it as differentiating x squared with respect to x. And the result is 2x using the power rule. We have gone through the power rule already. We have actually finished it. So we are now going to move on to, can we now turn to page 11? Now, we last stopped at page 11. I think these were the 4 examples. And then we moved on to the constant multiple rule already. This is rule number 2, the constant multiple rule. Now, the constant multiple rule says that you can apply the power rule, which is for this part, even when there is a number k that is being multiplied in front. Now, what you do to the k is you simply multiply it to the rest of the power function. Example, differentiating 5 and then x power 7. Now, this x power 7, obviously it is 7 come down, and then x, and then 7 minus 1. This is the result of the differentiation. And you actually see this in yellow. Now, what do we do to the 5? We take the 5 to multiply the 7, which gives a 35. Okay, so this is the constant multiple rule. Now, with that, We have done a few examples. You can actually use the SLS Math Feedback Assistant to check your answer. But for now, let's just run through the questions. Anyway, this page was all homework. You should have finished this page already. Let's check the work. Now for this particular questions on this page, they introduce the symbol y. So you can straight away do a dy dx. Now, first question. Dy dx equals to 3 bracket, the 20 comes down, x right there, and the 20 subtract 1. The result is 60x power 90. Now, before I move on, some of you may realize, hey teacher, actually why must I do this step? If I can see the answer just by imagining 3 times 20 to give 60, and then later on, the 20 go and subtract 1 to give 90, can I actually skip this working and straight away jump to this? Actually can. If you can see it fast enough, you can actually do it. Okay, but we'll do that later once we get used to the technique. For now, let's just write all the working. Now let's go to part B. Now part B is something that I told you to memorize last lesson. But anyway, if you've forgotten, the result is dy dx equals to 4. Now why 4? Where is the working? Let's see the working. Originally, 4x actually means 4x to the power of 1. The 1 is invisible. If I do a dy dx using the constant multiple rule, it says that 4 bracket 1 comes down, x remains there, power 1 minus 1. Now if we simplify this becomes 4 times 1, which is 4, x power 0. Now x power 0 is just 1. So what is 1 times 4? It is just 4. Now at this point, there are some things I need to memorize already. If I give you y equals to 4x, you need to be able to tell that dy dx is just 4 using the constant multiple rule. When y equals to 5x, dy dx must be 5. When y equals to 7x, for instance, the dy dx must be 7. This formula even works for fractions. For example, half x. The dy dx in this case must be half. It even works for decimals. 0.57x, the dy dx must be 0.57. It even works for pi. Now take note, pi is just any number. It is just a number. Now when you see a pi, which is the number, the dy dx is just pi. This you must memorize. Right? You must memorize, which is very important for part B. Okay, take note, this is an important question to revise. Okay, for revision, and you must memorize. Let's move on. Part C is fairly simple. Dy dx is 2 bracket negative 5x power negative 5 minus 1. Now, if you can see the answer straight away, in fact, you could have just said 2 times negative 5 straight away give negative 10. Negative 5 subtract 1, the power is negative 6. Alternatively, you can go through this long working to still get this answer. So I hope you are gradually getting a little bit faster. Alright, now anyway, for this question, to rewrite the x power negative 6 as positive power, you have to write it this way. Negative 10 in the numerator, denominator x power positive 6. Let's go to part D. Now this question, I must first write y equals to 5x, or rather 5 times 1 over x first. But we know that 1 over x is the same as x power negative 1. There is actually an invisible 1 here. So if I convert using 1 over a power m, convert to a power negative m, this is how the conversion works for indices. Now once that is done, I can begin the differentiation. The dy dx equals to, okay, can we get a bit faster already? What is 5 times negative 1? Negative 5. X remains there. What is negative 1 minus 1? It should be negative 2. And the answer is negative 5 out of x squared. Now if this is too fast for you, you can do it the longer way. Okay, let's show the longer way on the right hand side. Those who need to do it in the longer way, this is your working. Dy dx equals to 5 bracket. The power comes down, the power reduces by 1. So negative 1 subtract 1. You will still get the same answer. Let's move on. Now for this question, this is a very, very important question you must revise, especially for the exam. Why is that so? This question, a lot of students tend to make mistakes because of the number 4. Now for this question, you need to realize that 1 over 4 is 1 quarter. It is not 4, it's 1 quarter. Now the x power 3, if I bring it up as a negative power, it is actually written as 1 quarter x power negative 3. Now if I apply the the constant multiple rule, this is the constant, this is the product, the power rule. Okay, let's do the differentiation. The dy dx is 1 quarter, the power comes down, the x remain there, the power reduced by 1. If you can do this a bit faster without this technique, go ahead. Anyway, you should get a negative 3 quarter x power negative 4. Now this x power negative 4, to write it in positive index, you have to write it in the denominator next. Negative 3 on top, 4 below, and x power positive 4. That is the result for part D. Let's go to part E. This question, you need to write it as 8 times. Now square root x is the same as x power half. Now let's begin differentiation. Can you go a bit faster? Power comes down. So what is half times 8? That's 4. Power reduced by 1. What is half subtract 1? Negative half. If you can't see it so fast, this is the full working. Okay, but gradually you must be able to do this part fast already. Anyway, the result is 4 divided by x power positive half. But what is x power positive half? Actually, it is just square root x. This is the final answer. Let's go to part F. Now part F is tricky. First, you must write the 7 over 2 first. Right? 7 over 2. Next, please be careful about your denominator. This part in yellow, this is actually x to the power of 4 out of 3. One more step, 7 over 2, and then x power negative 4 over 3. Okay, I remove it out of the denominator. You must write like this. Let's begin differentiation. Dy dx equals to 7 over 2. Power comes down, and then the power subtract 1. What you will end up with is negative 14 over 3, x to the power of negative 7 over 3. Now written in positive indices, you will have negative 14 on top, 3 below, and cube root of x power 7. Now if you have forgotten how I did this, remember this indices law. Okay, which also means like that. Remember where to place the numerator and denominator of the fraction here and here. Let's move to this one. Now the next one, those who are fast enough will realize, teacher, all I need to do is to take the 0 come down, 2 over 7 times 0, whole thing is 0. Well done. You are correct. Okay? If you cannot see what I'm trying to say, then you just do it slowly. 2 over 7. 0 comes down. 0 minus 1. But what is 0 times everything else? It is just 0. Now at this point, do you also realize that 2 over 7 times x power 0, this part is 1, this is just y equals to a constant number without x. Does that mean that every time I have y equals to a constant, the dy dx must be 0? In fact, it is true. So for instance, y equals to 4, constant, right? This constant, no more x already. The dy dx is 0. When y equals to 5, the dy dx is also 0. When y equals to 6, the dy dx is also 0. For those who are not convinced, let's just use one as an example, this one. Y equals to 5 also means 5 times x power 0. Because this part is a 1, 1 times 5 is still 5, right? So actually this part is invisible, but it's there. If you do your dy dx, the moment the 0 comes down, everything else multiplied to it will give us 0. And that is why we have 0 here. So let's carry on. Y equals to 7. By the same logic, dy dx must be 0. Y equals to 2 over 7, which is what we saw just now. The dy dx must also be 0. When y equals to 0.72, for instance, the dy dx is also 0. In fact, when y equals to pi, which is just any other number, there is no x, the dy dx is also 0. Now what I have just covered is something known as the constant rule. We are going to come to it in a while. Okay, but remember this first. Alright. The next page is also homework. This was supposed to be done as homework. I'm going to flash the answer in a while. Check through all your work first before you verify the answer. Alright. For the you do example 2, I'm going to do it a bit faster now. For the first question, the dy dx equals to, power comes down. So 5 times 9 is 45. The power reduced by 1, so 9 minus 1 is 8. Now if you want to do it by the long way, go ahead, but this should be the final answer. If you can do it faster, you should do it faster already. Next one. Hey, this is the one that we are supposed to memorize, right? Half x. The moment there is just an x, remember? This one. Just an x, x. You just take that number. That is the result. Okay? So without any questions asked, part B, the dy dx is just half. There's nothing else to do already. Next question. Dy dx. Let's do it a bit faster also. Power comes down. So negative 6 times pi is negative 6 pi. Then x. Power minus 6, subtract 1. That becomes negative 7. Written as positive indices, 6 pi on top, x power 7 below. Next question. Rewrite this as 7 times 1 over x. And then remember there's an invisible power 1 here. And this is actually the same as 7x power negative 1. Okay, let's begin differentiation. Dy dx is, let's do a bit faster. Negative 1 comes down and multiplies 7. That gives a negative 7. X remains there. Negative 1 subtract 1 is negative 2. Written as positive indices, you have negative 7 on top, x squared below. This question, tricky question. Write this as 3 over 2 first, and then the x power 4 move up, it becomes x power negative 4. dy dx. Okay, for the sake of this question, because got fraction, I shall do it a bit slower. 3 over 2. Power comes down. X power subtract 1. Now let's press calculator. This part is going to give you a -6. This part is going to give you a x power -5. Written in positive indices, you have -6 on top, x power 5 below. Part E. This is y equals to 3x power half. Let's begin differentiation. Let's do a bit faster. Half comes down, if you times 3, it becomes 3 over 2. X power half subtract 1 is a -half. Sorry about that. -half. Now this means that if I write as a positive indices, the 2 is below, the x power half is below, but x power half is the same as square root x. Okay, and we are done. This question, y equals to 5 over x power 1/3, x to the power -1/3, and now I begin the differentiation. Dy dx equals to power comes down, multiply, that gives you a -5/3, and then the power subtract 1. Which can be written as -5 on top, 3x power 4/3, and you can write it some more as -5 on top, 3, and then a cube root of x power 4. Lastly, hey, this is the one that I say y equals to 9 times 1, which is 9, right? The dy dx straight away is 0. This is the constant rule that we mentioned over here. If you want to do it the long way, you can just say that from here, the dy dx is 9, power comes down, power reduced by 1. But remember, the moment there's a 0, this 0 will multiply everything to give a 0. So you can actually memorize this and the result is just 0. In other words, when y equals to a constant number without the x, you perform the dy dx, the result must be 0. Okay, with that, we are done with rule 2, and that is constant multiple rule. Moving on to the third rule. Now, the third rule we have covered earlier on already. It's known as the constant rule. If you see a constant number without x, dy dx must be 0. So, this page, when there is a constant k, which is basically just a number, a constant number. Now, there is no x involved, the dy dx must be 0. Okay? The full working is this. But by now, you should know that it is 0. So I'm not going to go through the long step anymore. And by the way, do you realize, for example 3, all are constant numbers, even the pi, constant? Yeah. Without any questions asked, dy dx is 0. dy dx is 0. dy dx is 0. And dy dx is 0. No working at all. Let's move on. You do, but you should know by now, all are constant numbers. Dy dx is 0 for all these cases as well, even for fractions. Even for 2 over pi, which is just any number. 3.2 is a decimal, it is just a number. The dy dx is also 0. And that is constant rule. Done. Okay, what are we left with? For 12.1, we are left with this sum and difference rule. Now, this is actually a combination of everything that we have done so far. So there is no new technique. It is just a combination. But now, the only difference is you might see plus or minus in the question already. Okay, and there are two things that you need to differentiate at one go. Sometimes you may even differentiate up to 3 items. Example, you may be asked to differentiate x power 7. Okay, this one is easy. You will use the power rule. You can be also asked to differentiate this, and this is none other than the constant multiple rule. The only difference now is there is actually a minus sign in the middle, and you just write minus accordingly. Alright, that's all. Now let's do these examples. First question. There are two terms, all written nicely already. You can apply power rule directly. dy dx is 7x power 6. I'm going faster already. 7 comes down, the power subtract 1, that becomes 6. Now for the other side, power comes down, power reduced by 1. So negative 3 minus 1 will give a negative 4 in a while. So this is 7x power 6 minus 3x power negative 4. Your final result, you write this as 3 on top, x power 4 below. Okay, sorry, the division line is a bit too long. Let me adjust it. Okay. Oh, sorry. Yes, that's right. Okay, how come that now is a minus when we started with a plus? It's because of this part. Plus times minus is minus, so be careful of the operations. Moving on, this question. Now before we start, let's rewrite 1 over x, and there is an invisible 1 here by the way. This is x power negative 1 minus x power 2/3. Recall your indices law. This is all indices. We can now begin differentiation. Power rule. dy dx is negative 1 comes down, x remains, power minus 1. Minus 2/3 comes down, x remains there, 2/3 subtract 1. Negative x power negative 2 minus 2/3 x power negative 1/3. Let's simplify this. This is negative 1 on top and x squared below. This is 2 on top, 3, and then x power 1/3. But what is x power 1/3? X power 1/3 is the same as cube root of x. That's it. Let's move on. Okay, there are two terms. I can do the differentiation easily. dy dx equals to 10x. Okay, how do I get 10x? 2 comes down, so 2 times 5 is 10. And then 2 subtract 1 is 1. There is an invisible 1 here, which we do not write. Okay, now this one, familiar. There's only an x, only one x, number times x. What did we do previously? This one, number times x. The result is just a number. So for this case, the y at the back after differentiation gives a plus 4 over 7. Full stop. There's no more x already. Part D. Now this one, please rewrite first. The middle term needs to be, you need to rewrite as minus 3 over 4 and then x power negative half. Okay, maybe I don't jump steps. Let's do it again. Y equals to 3x power 4 minus 3 over 4 x power half. Okay, because square root x is x power half plus 5. One more step before I differentiate. 3/4 right at the side. Now a positive half, if you bring it on top, it becomes x power negative half. Okay, let's begin. Now this question involves constant multiple rule for these two. Now this one is special. This is the constant rule. What do we know about constant rule? The result must be 0. Okay, let's begin. So the dy dx must be 4 times 3, 12. 4 subtract 1, 3. Done for the first term. Second term, a bit complicated. Okay, let's do it slowly. Negative half comes down. Negative half subtract 1 for the power. The yellow part, plus 0. Nothing else that we need to do. Okay, let's simplify this. 12x power 3. Negative and negative is a plus, so plus 3 over 8 x to the power of negative 3 over 2. The plus 0 is gone already. Okay, let's simplify this. 12x squared plus 3 on top, 8 below, x power 3 over 2. Let's simplify a bit further. 12x squared plus 3 on top, 8 below, square root of x power 3. Please recall your law of indices. Okay, you need to know your laws of indices really, really well. For this particular case, we are using the one where the denominator in the fraction is a 2. This becomes square root of a power m. You need to remember this indices law. Alright. And we are done for today's lesson. Okay, so in class we stopped here. I have a homework for you. Please go and work out you do example 4 by the next lesson on Monday. Okay, by next lesson on Monday, make sure that you do example 4 is completed, and I will check answer on Monday morning. Okay, that's all for today's lesson. So let's summarize. Today we re-looked at rule 1, which is power rule. Then we move on to rule number 2. Rule number 2 is known as the constant multiple rule. There's a constant. In the constant multiple rule, there are some special cases where you must memorize. When you see x alone with a number, the result of the differentiation is just that number. There is one more result that leads to the next rule, which is the constant rule. If you see a constant number without any x and you differentiate it, the result forever is 0. And that's why you see all are 0. Lastly, we saw a combination rule where you must use all the rules you have learned so far and do everything slowly, one at a time. Now, even though I say slowly, by now, everybody should be able to see the answer for example this question really quickly. You shouldn't be doing a slow and steady method. dy dx is 5 bracket 9 come down 9 minus 1. I'm so sorry, you don't have the luxury of time like this in the exam. If the question is so simple that you can visualize it immediately, get to this answer straight away. I mean this answer straight away for such an easy question. Okay, if it's a difficult question with a lot of fractions, okay, so be it. Do it a bit slowly. But the moment the numbers are nice, please do not show this read working anymore. Go to the final answer immediately. Alright, with that, we end today's lesson. Thank you very much.